A swimming pool holds 30,000 gallons of water. The graph shown below represents the amount of water in gallons in the swimming pool as the pool is being drained. How much time in minutes does it take for the swimming pool to be completely drained? So if the pool is being drained, it means that the water is coming out and we're going to have less and less water in the pool. Now most graphs are not going to have all the way up to 30,000 on it. So notice our scale over here on the y-axis. This is going to be very important for later on. It only goes up to 30, but this is represented in thousands of gallons. Our job is to again find how much time in minutes does it take for the swimming pool to be completely drained. One strategy we could do is extend this line further. We are looking when it is 0, which would be somewhere over here. Notice it is about double the distance that we had on our original graph, which stopped at 150. If you had no idea what to do, one test-taking strategy would be to figure that out, and our best option would be option B here of 300. Now we're going to mathematically solve and show why that is a correct assumption. We have here an equation of the line that we're trying to build. That equation of the line is in the form y equals mx plus b, where the b is the y-intercept and the m is the slope. We have to be very careful how we handle this because our b is up here. While it shows 30, this is actually 0, 30,000, which means the y-intercept, or b value here, is going to be plus 30,000. Then if we build our little triangle to calculate the slope, I'm going to pick another point on here. I'll just pick this one as my second point, and as we build the slope here, our slope triangle, it is going down 3, but this is specifically going down 3,000. And then it is going to the right by, let's see here, from 0 to 30, just 30. So my slope here, it's going down, which means that would be negative 3,000, rise over run, over the 30, and then we'll want to reduce and simplify this equation. This becomes y equals negative 100x plus 30,000. Going back to the problem now, we are trying to figure out when the pool is completely drained. Completely drained means when y is 0. So if I plug in 0 here, 0 equals negative 100x plus the 30,000. If I were to solve for x here, I would want to move that negative 100x to the other side by doing the inverse. Add 100x to both sides of the equation. When I do this, I then get my 100x equals 30,000. And then to solve for x here, what we might want to do is to move that 100x, just the 100 away from that x. The x isn't coming with, so we got to separate it and divide it by 100 to both sides of the equation. And then we get that when the pool is drained, my x value is going to be 300. So again, we can mathematically solve it, or using a test-taking strategy, we could have extended the line, figuring out that it would fall over here. Let me extend the x-axis a little bit as well. We're essentially looking at what this point over here is for that x value, and this x value over here would be the 300.